Hi, I'm Miss Hearn. Let's get started. In the previous video, we saw that the square root property can be used to solve various equations, such as the one at the top of the screen. And now we're going to expand on that idea. It turns out that the square root property can be used to solve any quadratic equation. But a process called completing the square has to be done first to make that happen. So we're going to start by looking at what are called perfect square trinomials. So notice that the binomial, two-term polynomial, x plus 3, when you square it, gives you the trinomial x squared plus 6x plus 9. You can confirm this by foiling it out. And I want to make some observations about the relationships between the numbers 3, 6, and 9 here. Notice that if you take half of 6, you get 3. And if you square the 3, you get 9. Well, it turns out that these relationships are true in general when you're talking about what's called a perfect square trinomial like this one that can be written as a binomial squared. Another example of a perfect square trinomial would be something like x squared plus 8x plus blank. I can actually figure out what would make a perfect square trinomial because I'm going to take half of the 8, much like half of 6 was equal to 3, half of 8 is going to be equal to 4, and so I know that the trinomial I'm about to construct is going to factor into x plus 4 squared. All I have to do then is square the 4 to figure out what goes in the blank. 4 squared is 16. If I have a 16 here, I create or complete a perfect square trinomial that factors into x plus 4 squared. Let's practice constructing perfect square trinomials. So these questions were taken from Alex. In this first one, it says, completing the square. Fill in the blank to make the expression a perfect square. And we're given u squared plus 2u plus something. So the procedure is you're going to take half of the coefficient of the linear term. In terms of the standard form of a quadratic, ax squared plus bx plus c, we're talking about taking half of b. In this case, half of 2 would be 1. And then the number that you get from taking half, you're going to square that, in this case giving us 1. And this number, 1, goes here, making u squared plus 2u plus 1. And this number 1 that you got when you took half of the coefficient of u, that one is actually what you use to factor. So we have a perfect square trinomial, u squared plus 2u plus 1, which factors into u plus 1 squared. Now in Alex, all they're looking for in this problem is to put the 1 in there. But the fact that it will factor into a quantity squared is going to be important when we're working inside of an equation and we want to use the technique of completing the square to solve that equation. All right, so classwork number 3. The first 2 classworks for my class were in the previous video. If you're in my class and you have to submit your classwork, this is classwork number 3. You're going to do the same thing. Fill in the blank to make the expression a perfect square. And the procedure is you're going to take half of b and square it. And that's going to give you the number that's going to go into this box. So pause the video and see if you can get that answer correct. Please keep in mind that b in this case is negative 12. It includes the negative. All right, so let's see what you got. Half of negative 12. Well, that's the same as negative 12 divided by 2, which is negative 6. Now we're going to take negative 6 and we're going to square it. And that's going to give us the number that goes in the box. Now when you square it, it changes it back to a positive. So you might say, Miss Hearn, why does it matter if I use the negative? Well, you're going to see later that it does matter for another part of the process. And that is because u squared minus 12u plus 36, this perfect square trinomial that we just created, if you want to factor it, it's always going to factor into u and then whatever you got when you took half. So if it's positive, you'll put a plus. If it's negative, like in this case, you'll put a minus here. All right, moving on to how we actually use this idea to solve an equation by completing the square. So here's an example. Solve x squared plus 8x minus 56 equals 0 by completing the square. Okay, this first time through, I'm not going to list any steps. I'm just going to kind of demonstrate for you how this procedure works. The idea is that we want to get this in the form of something squared, so like x plus a number squared equal to some other number. That's our goal. Then we can use the square root property. In order to make that happen, we're going to actually move this 56 out of our way. So I'm going to write x squared plus 8x equals and add the 56 over to the other side. And then I'm going to think about what number I could add here to make this a perfect square, just like we did a minute ago. But since this is in the context of an equation, whatever we do to one side, we have to do to the other. All right, now how do I figure out what's going to go in the box? I take half of b. b in this case is positive 8. Half of positive 8 is 4. But that's not the number I add to both sides. You then take that number and square it, and you get 16, and that's the number that goes in the box. So we're going to put 16 on both sides. All right, now the next thing I'm going to do is on the right, I'm just going to add those two together. That's going to give me 72. And then on the left, I have to factor this. And because of the way I chose the number 16, I know it's going to factor into a binomial squared. But what binomial squared? Well, it's going to start with an x for sure. X times x is x squared. And notice that this number 4 squared is 16. And in fact, that's exactly always whatever number you got when you took half, that's what's going to go right there when you factor the left-hand side. Okay, so now we have a very nice form for solving the equation, for finding the x value that will make, or values actually, that will make the statement true. Because we have a quantity squared equal to a number, we can use the square root property. It says that if x plus 4 squared is 72, then x plus 4 must be plus or minus the square root of 72. If you're not sure why, take a look at part 1 of this video series. So in order to simplify the radical square root of 72, there's a couple different approaches. One way is to think of the biggest perfect square that would divide evenly into 72. So I'm going to start listing perfect squares. 2 squared is 4. 4 does go in, but let's see if we can get something bigger. 3 squared is 9. Oh, that goes in there too. Divides evenly into 72. 4 squared equals 16. Not sure about that one. You can check on your calculator. Definitely that one doesn't go in. 6 squared equals 36 though. That factors into, that goes into 72 twice, so there's no way there's a bigger perfect square in there. So I'm going to go ahead and think of this as the square root of 36 times 2, or in other words, 6 square roots of 2. So we have x plus 4 equals plus or minus 6 square roots of 2. And we're going to subtract 4 from both sides to get the x completely by itself. And that'll give us x equals negative 4 plus or minus 6 square roots of 2. So our two solutions are negative 4 plus 6 square roots of 2 and negative 4 minus 6 square roots of 2. All right, so that's an example of completing the square so that you can get the equation in this form in yellow here, so then you can use the square root property. So now I'm going to list out the actual steps that you will follow that will enable you to solve any quadratic equation by completing the square. So to solve a quadratic equation by completing the square means rewriting the equation in a form of a quantity squared equals a number, then using the square root property. The steps to solve by completing the square are: 1. Move the constant term to the right and the other terms to the left. 2. Divide both sides of the equation by the coefficient of x squared. 3. Take half the coefficient of x and square it and add the result to both sides. 4. Factor the left and simplify the right. And 5. Apply the square root property. So here I have an example that we're going to use all of these steps for. 2x squared plus 16x minus 42 is a quadratic equation because it fits the pattern of ax squared plus bx plus c equals 0. So we're going to start by, and we were asked to use completing the square, so that's the technique we're going to use. So for step 1, we're going to move the constant term to the right and the other terms to the left. All right, so what is the constant term? The constant term is the c, the negative 42. We need to move that over to the other side of the equation. So we're going to add 42 to both sides, and that's going to give us 2x squared plus 16x equals positive 42. All right, the next step says divide both sides of the equation by the coefficient of x squared. That would be the 2 in this case. You always have to have just a plain x squared at the front for completing the square to work. So you have to divide, if there's anything in front of the x, you have to divide by it. So I'm going to divide both sides by 2. Make sure you divide every single term by that 2. So that's going to give us x squared plus 8x equals 21. Now I'm leaving a space here because I know that I'm going to have to take half the coefficient of x and square it and add that result to both sides in a minute. So I'm just thinking, okay, in the next step I'm going to be figuring out what's going to go in this blank here. So step 3, we're going to take half the coefficient of x. That's the b, by the way. You're taking half of b. Half of 8 in this case is going to be 4. And then you're going to take that result, 4, and you're going to square it, which gives you 16. This number 16 is what you're going to add to both sides of the equation. So we're going to have x squared plus 8x plus 16 equals 21 plus 16. Okay, the next step says to factor the left and simplify the right. So we're going to factor the left. Now, this always factors, if we did everything right, into a perfect square. And not only that, but the number that we got when we took half, is 4. I know that that's going to be used to factor. That's important because sometimes it's not so obvious how to factor. So x plus 4 quantity squared is going to be equal to, now on the right we add those two together, we get 37. So x plus 4 squared equals 37. This is great because now we can use the square root property, which is exactly what step 5 says to do. Apply the square root property. If you have a quantity squared equal to a number, then that quantity without the square is plus or minus the square root of that number. So we have x plus 4 equals plus or minus the square root of 37. Now we just need to isolate the x. So what I mean by that is we're going to subtract 4 from both sides. So our final answer is that x equals negative 4 plus or minus the square root of 37. Now those are not like terms, we cannot combine them. So when we enter our answer into Alex, we're going to put negative 4 plus the square root of 37 and negative 4 minus the square root of 37. And 37 cannot, the square root of 37 definitely can't be simplified any further. 37 is a prime. All right, well, I hope you found this video helpful. If you did, please remember to give it a thumbs up, which helps other students to find the video.